Okay, so you guys got two handouts today. You got assignment 104 and you also got exercise 114. We'll talk about 114, which is essentially an extension of what you did last class in a little bit more detail in a bit. But I want to introduce and talk a little bit about assignment 104 right now. This assignment is due on Monday the 4th of April, which is not the Monday that you get back from break. I thought that was cruel and unusual punishment, right? I'm one of the few people that believe break means break. So it's my goal to make sure that you are, in fact, on break, at least from this class. So it's kind of weird, though, because break falls, and it means it's kind of choppy with your two assignments. They get due very close together. Oh, no, you guys just turned in the poster. Never mind. So you're fine. It's my other class that they get choppy. You guys are fine. Don't worry about it. The other thing that I will say is that this is, it's not something that you have the skills yet to do, but you can definitely start looking at Charlie Harper and kind of take a glance at his work and see what might be in the general vein of what you're going to try to do. You will be creating your own version of his work, so it's not a direct copy of anything that he's done, but I've found in the past the easiest way for people to really do this and to do it well is to mimic or to look at an image that he did and then kind of make it your own version of it, change a few of the elements that make it yours. Sometimes people have trouble with the way that it flattens and kind of his style. It works really, really well for vector-based graphics programs to do this as an assignment. It's a great test of your abilities. Certainly will test your pen tool, but there's a little bit more to it. Today we're going to talk about vector graphics versus raster graphics, and I think it's really an important distinction because as you go forward in your design careers, you're going to be using both of these types of programs, and it's important to know when one is an advantage and when another is an advantage. So we're going to spend a little bit of time talking about that, and then we'll move forward and do some more Illustrator before your break, and then we'll come back and do a little bit more after break. We're going to talk about logos next class, so you'll actually be designing your own logo, and you'll see that I refer to logos a lot in today's lecture, so it's kind of a natural extension. When you get back from break, we'll talk about color theory on that first lecture. Reminder, that's when Daniel's coming to evaluate me, so make sure you show up. All right? Hint, hint. And so we'll talk about color theory and what colors mean and how you pick a particular color palette and that sort of thing, which I think is particularly relevant in this kind of design era. And then after that, we'll do architectural diagrams, which is one of my favorite lectures to give, and it's something that you will find very, very useful as you go forward in your careers as architecture students. So give me just a second to make sure that of course, right? I have everything set to go, and then I let my iPad go to sleep, and it no longer connects. Thank you so much. Hang on. Okay, so sorry about that. So let's talk a little bit about vector versus raster graphics. And I'm going to start with raster graphics, which is kind of how we started the semester in the first place. So we dealt a lot with photos in Photoshop, and that as a processing engine and also photos as an entity are raster graphics, which basically means that there's a bunch of individual little squares that make up an image. So you guys all saw this when we were working in Photoshop and you kept pressing Control+ and you zoomed in. At some point, all you'd see were square pixels of certain colors. Okay? That is, by its nature, a raster image because it's just those square pixels. The more you zoom in, the more you're going to see something like that. So raster graphics do have some huge advantages. If we're dealing with images that are like photos, for example, we have the ability to manipulate any one of these individual little squares in almost an infinite number of ways, because all it is a square that's assigned a particular color. We can do anything to it. This lends itself really nicely for the world of photography. We can do adjustment layers. We can do all the kinds of things that we've been doing in Photoshop. It works really, really easier. It's easier to edit in that you're just editing this pixel, change it to that color. So we can use things like the clone stamp tool. Take this region, copy it over to here. Right? All we need is those individual pixels, and we can apply them in an infinite number of ways. Right? We can also do some kinds of fancy effects to a particular image rather easily. You guys didn't play with Photoshop effects too much, but there are things like take this image and convert it into some kind of a line drawing, or convert it into some kind of a stylized watercolor painting or sketch or something like that. Very, very easy to do in Photoshop. You just click a few buttons and it does it, because it's just distorting the pixels themselves. There are, however, some disadvantages to raster graphics. So if we zoom in, this is the nature of a raster graphic, at some point we're going to get a bunch of little cubes and it's going to get distorted. And so we don't have the ability to infinitely zoom. So let's say, for example, that you had an image and somebody came to you and said, guess what, I have a billboard on the side of the highway and I want to put your image on the billboard. Okay? Chances are you didn't shoot your image in high enough resolution to do it on a billboard. And it would look like a bunch of little individual squares by the time you blew it up that big. So we have to think about, what is this resolution? Now, could you have shot the original image big enough to blow it up that big? Sure. But you have to think about it in that context. It's not something that you can go back and add more pixels. You can't add more information. It'll still look blocky. The other thing is that file sizes are very, very large. So if we think about a file size for a raster image, we have to concern ourselves with every pixel that goes across the page. If we had 10,000 pixels wide, right, there'd be 10,000 pixels worth of information, times however many pixels it is long. 5,000 pixels long, there'd be 5,000 times 10,000, and we'd end up with a lot of information to store. Vector-based graphics, which we'll talk about in a second, requires only 4 pieces of data to store the same, essentially the same image. Let's say we had an image of a square, for example. The other thing is that raster images take a lot more computer memory, space, RAM, CPU power, etc. to work on. You guys may have noticed this in the world of Photoshop. When you were working on Photoshop, you could potentially have created these giant Photoshop files. Right? Every time you create a layer, it's another set of pixels that it's remembering. So it's not uncommon for a Photoshop file to get upwards of 500 megabytes. Even though you started with an image file, it's maybe 16 or 20 megabytes. So they can get really large really fast. And so that's definitely a disadvantage. So let's move forward into the world of vector graphics. Vector graphics are defined by mathematical formulas. So things like lines, rectangles, circles are all defined by a set of control points. And then the computer plays connect the dots and connects the individual dots to make whatever shape it is. So if I had, for example, a square, right, and I'll draw up here, all I would need is 4 dots on each of the corners, and the computer would say, oh, I can connect the dots here, 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 and here, and suddenly you have a square. Likewise, I could control what the line is that connects the dots, independent of what it's filled with. So I could change the color, for example, and I could have the inside have a certain fill color. It doesn't take any more information. It's still defined by those 4 corner points. It just says, hey, inside of these 4 points, fill it with yellow. Connect the lines together and fill those lines with blue, or make those lines blue. We can take it a step further and make any shape. I'm just saying a square because it's a particularly easy one of defining. Right? 4 points, we have a square. Circle, center, radius, draw the circle. Again, mathematical formula. Okay? If we get into some kind of a fancy line that goes like this, oops, wrong here. Fancy line that goes like this, there's still going to be, as you know from your font exercise, there's still going to be control points along that line that define the shape and the curvature of that particular line. So it's very, very low in its amount of information that's necessary to store on the particular computer. Advantages, it's completely scalable. Right? So I could come to you and say, I want to do that billboard. If you drew your image or you did your text in vector-based graphics, no problem. We'll scale it up as big as you want. And it'll still be perfectly sharp because it's not defining pixels. Right? It's just defining math. Make that line bigger, makes it bigger. No problem. Okay? There's a reason that most of our 3D modeling, drafting, i.e. AutoCAD, Rhino, SketchUp, are vector-based graphics. Right? We want to be able to draw full scale. We want to be able to scale down and not have things pixelated. We want to be able to scale up. Right? So it's scale independent. File sizes are very small because it's just, hey, here's a couple control points and that defines this whole thing. Okay? It's much easier on the computer, lots of less, I can't even talk anymore, much less memory, CPU power, etc. to work on one of these files. Of course, these have disadvantages as well. Vector images are not good for photographs because photographs can't easily be defined by mathematical curves, for example. So if I were looking at this particular image here, right, and I were to look at her face, right, the photographic example is easy. It's just a bunch of individual little pixels that make up one pixel's brown, one pixel's skin tone, one pixel's a little bit darker skin tone, etc. Okay? If I look at it in vector format right over here, right, we can see that it's already trying to make shapes out of the various color regions. Right? A face isn't nicely defined by, say, a curve that's there, and this little curve that represents her hair, and those ones, right? And then we fill in a region that's like this, and then we fill in another region like that's like that. Right? It doesn't lend itself to these shapes. And we can see that the end result is not a photograph. It's a drawing. Right? So one is for drawing, and one is for photographs. I thought I got rid of that beep. I'm sorry. So when do we use a raster graphic, and when do we use a vector graphic? Should be relatively obvious. Photographs, of course, they're raster graphics. Okay? But the other thing, some of you are in the Rhino class, so we've talked about Rhino a little bit before. You're familiar with things like V-Ray, right? HDRIs that we put into the background images, those have to be high dynamic range images. Those are, in fact, raster-based graphics. We need all of those pixels. We actually need more pixels than you can even see, but it's still raster-based, not vector-based. Okay? Vector, on the other hand, would be things like line drawings, AutoCAD, etc. Those kinds of drawings, 3D models in addition, logos, things that you want to be able to blow up to be much larger. Right? And guess what? Fonts. You work with vector graphics almost every day when you type letters. You've ever noticed you can select the font and just say make it bigger? Right? 100 point, 72 point, whatever. It just gets bigger, but it still looks really clean. All the edges look clean. It's not pixelated. That's because it's vector-based. It's defined mathematically, and you can make it as large as you want. So let's look at a few examples here. If I look over on the left side, this is a pretty good kind of rundown of what's happening in this particular brochure. Doesn't matter what the brochure is about. It's just a good telltale. So we have vector graphics that would represent up here at the top. That would be the logo, the text, those kinds of things. At the bottom, we'd have a little bit more text. Again, that is vector-based because we want it to have that scalability. The logo might be much, much larger, and we scale it down to fit without any problem. Right? Likewise, maybe the logo is small, and we scale it up. It doesn't matter. The bitmap file right here in the middle, that's the image file. So that is, of course, a raster graphic. So we're combining the two together. InDesign is really, really good at combining things together. By its nature, we'll talk about programs in just a second, InDesign is a vector-based graphic, but it can accept raster-based graphics and use those. Right? In a way, Photoshop can too, because there are a few things in Photoshop that are raster-based. But most of what you're doing doesn't have anything. So if we look at this chart over here, this is a really good example of how it affects size, file size. So the image that we're looking at here, that's the logo that they're talking about. And we have a variety of resolutions. The first one here at 250 by 78, the vector size is 36 kilobytes. Again, very, very small. The raster size, not too bad, but it's almost double the size. Still small, but it's almost double the size. So let's say we scale up to 800 by whatever, I just drew a line through it, 248. Okay? We get the same size right there, same 36 kilobytes. Doesn't matter the size. Right? The file size stays the same. We move up here, 581 kilobytes. Big jump. Okay? Let's go up one more, 1500 by 466. Again, not too big of a difference, but at the same time, there's our 36, the same. But over here, almost 2 megabytes in size. So the larger we make this image, the bigger these file sizes get. where the vector file sizes stay very, very small. So it's important to distinguish there's a distinct difference between those two. Bitmap's the same thing as a raster image. Bitmap is the most generic form of a raster image. So it has no compression. When we talked about image formats way back when we were doing the photography section of the class, we talked about JPEGs as the primary example of what we work with every day. Those are compressed format raster images. So we've taken all those little squares, we've eliminated some of the squares to make the file sizes smaller based on the size that we need, and that's what we get. A bitmap image is essentially just, here's my row of pixels, here's all the colors. There's no compression, there's nothing on it. So it's about as generic as you get. Okay, so the website that I took these illustrations from used bitmap interchangeably with raster. So I should go through and correct those. Okay, so here's another example. This is the logo that they have right up here. Right there is that logo. If we zoom in on this corner right here to there, this is nice and sharp right along the edge. So that's going to stay. You guys can't see that because it's orange. Maybe we can see it better here. Right? That's going to stay nice and sharp all the way along the edges, right there and right there. If we were, instead of having it as a vector-based graphic, if we were instead using it as a raster graphic, we get this result, where the edges on either side become totally pixelated. As we blow it up, they become these big stair steps, these big jumps. So it's a distinct difference when we blow it up. So let's look at computer programs. Obviously, we're familiar with the raster programs because we did Photoshop. GIMP is just a version like Photoshop. But other things that work that we use every day, things like V-Ray. Well, maybe you guys don't use it every day yet, but you will, right? Especially after 136. If you think about things like V-Ray, that's this raster image, right? It does a bunch of calculations. It traces the rays through a particular scene. But what do you get? You get a JPEG image out of it, right? So it's ultimately a raster-based program. Vector-based stuff are things like Illustrator. No surprise I'm talking about this. We're covering Illustrator. They, of course, go hand in hand. But we also have things like InDesign, right, which looks very similar to Illustrator when we're working on it. But even more importantly, things like AutoCAD, Vectorworks, Revit, Rhino, SketchUp. Those are all vector-based programs. Okay? There's a subtle distinction between vector-based and things like 3D Studio Max, which are technically solids-based. It's a little bit different in how they work. But the concept is very much the same. So one of the really great things about all of these vector graphics programs is generally once it's a vector graphics-based file, it's generally interchangeable between them. So you will see in Illustrator, for example, that we could open up an AutoCAD file. In Rhino, we can open up an Illustrator file. In Rhino, we can open up an AutoCAD file. So we can go back and forth between these programs as long as the program can understand and read the mathematical formulas that define the shapes. Obviously, if I took a 3D model from Rhino and threw it into Illustrator, it wouldn't know what to do with it, right? So there is some complexity there. But at the same time, there is a fundamental intercompatibility with all raster-based image files. OK, so we're going to move, and I'm going to switch computers, and we're going to finish up with exercise 114. And then you guys will be free to work the rest of the day creating the rest of your lowercase letters. And then you'll make a font, and then you'll be done. So bear with me while I switch over. OK, so I'm not going to spend a whole bunch of time going through this and actually making you watch me finish all of the letters. Right? I went ahead and I did this as homework so that it would be ready so that you don't have to sit and watch me do the lowercase letters. Essentially, using the pen tool and working with the lowercase letters is the same as working with the uppercase letters. When you finish your lowercase letters, and let me turn off the guides for a second, or your uppercase, it will look like this. Right? You're all done with this particular page. At that point, if you open up your layers window, so if it's not available over here on the right, remember it's under Window and then Layers. And what you're going to do is turn off Font Page 1 and the Page 1 layer. And we'll get to just a blank white page. Then I'll go ahead and turn on Page 2, which gives me the template. And I'll go ahead and turn on the font Page 2. This will be the layer that you actually draw the font on, if you haven't done so already. So you go through and you'll make out the rest of the letters. And then it comes time to actually export these and create the font from them. So we're going to start, and I'll turn these off, with the first page. which is right here. And I'll leave the guides off for right now. And I'm going to go to File and then Export. And notice I didn't do File Save for Web because I want a little bit higher resolution out of this, which will help the font translate better. So I'll go to File and then Export. And I'm not going to pick an AutoCAD drawing. I'm instead going to pick a PNG. And I'll save it as Exercise 114, page 1. And I'll go ahead and click Save. And it'll bring up the PNG Options dialog box. Here I want to make sure that the resolution is set to high, 300. And then I want to come down here under Preview, and I want to make sure the background color is white, not transparent. Transparent will be by default. I want it to be white. And then I'll go ahead and say OK. It is important to have on the background with the little QR code and these two black dots, because that will help register where it's looking for certain letters. Okay? You can't just export the font by itself. It won't know what to do with this particular page. So if I turn up these two, I'll get the same background with my black squares. And I'll go ahead and go to File, Export. And once again, I'll do Exercise 114, page 2. Save. Resolution of 300. Background color of white. I'll go ahead and say OK. And that then creates both files that I need to make this particular font. So from here, we're going to go to paintfont.com, which is the site that we're going to use to actually convert this. And it does a reasonable job, but not the best job in the world. So if it doesn't turn out exactly as you want it, it's just kind of the nature of using free things. So paintfont.com. And I'm going to click on this Upload Your Completed Templates. And then I'll be able to choose my file. And I'll choose page 1 first. So let me go to my, oops, sorry. Go to my flash drive. No, apparently I can't click today. And right here, I'm going to pick page 1, open. And then I'll pick page 2 for the second one, open. And then I can name my font. And I'm going to pick a file format of TTF. This is a TrueType font versus an OpenType font. It doesn't matter. All the operating systems can read either one, but I'll leave it as TTF. There are some advanced options. If I was creating something with a font family and I was doing like a bold version of a particular font, I could do it using this strategy. In this context, it's not really worth it because you're not doing a bold version, so we'll leave the advanced options off for right now. And then we'll go ahead and click on this Start Upload button. And when I do that, this does take a little bit of time to process. It's also possible that if you all do it at the same time, the website will crash. I've had that happen before. But hopefully it won't. So there it is. It's gone ahead and it's given me a font preview of what my font looks like. Looks like I'm having a little bit of issues with the positioning of some of the letters. The A's and the B's are a little bit high. The rest of these look reasonable. And so that's the kind of thing that does happen. It's a free program. We get what we get. All right. So then I'm going to go ahead and download my TTF font. And so we'll go ahead and download it here. There it is. And I'd like to be able to prove that it works. So I need to temporarily install it on this system. So if you guys remember back to the exercise, I think it was 110, the typography lecture, where we used that AMP font viewer to temporarily install a font. I'm going to do the same thing. And it should be under Resources. Oh, excuse me, Portable Applications. There's the font viewer. I'll go ahead and open that up. I'm going to install the font temporarily, so I'll go to Not Installed Fonts, and then I'll go to today's exercise. I had previously saved this font into today's exercise, so you don't obviously save yours. 135, 114. I thought I did. Maybe I put it in the fonts folder. Yeah, there it is. All right, so there it is. It loads up. I'm going to install it temporarily. Yes. OK, remember I have to leave this open. And now I want to prove that it works. And so if you go to the Digital Tools site and you go to today's exercise, 114, at the bottom of the page in the last part, there'll be a sample file that you can actually download. You could create it from scratch using the text that I have on the bottom of this page, but I tried to save you a little bit of time. If you right-click on the sample font.indd, you can save link as, save it to your flash drive. There we go. And then we can go ahead and open that up. And for some reason, my computer decided that it didn't think that was an InDesign file. So let me go ahead and just open InDesign, and I'll open it from there. So let's open up InDesign. Perfect. And then I'll go ahead and open up the sample font.indd file. Of course, it doesn't exist, right? All right. So this comes in. I'm going to go ahead and select all of the text, and then I'll be able to pick my font from this list. If I can find it. There it is. And now it's been applied to that piece of text. From here, I can save this. So I'll go to File, Save for Web. Apparently I won't. Let me go to Export JPEG. And we'll call it samplefont.indd. Yes, I want to replace it. Maximum quality, 300. Export. And now I'll have this. This will then be the featured image. I'm going to upload this as the featured image and the TrueType font. So, and insert that into the post as well. So we have proof that this is what it looks like and that this is the file that I created of it. Okay? Remember, if your font isn't showing up, chances are you already had InDesign open and you need to close InDesign and then open InDesign again to see your font once it's installed temporarily. Okay? So again, today is very much about practicing with the pen tool. I didn't concentrate on that part of it, but it's just about giving you enough time to really get through all the letters and go from there. Next class, we'll be working in Illustrator again, and we're going to start doing logo designs. So if you have preconceived ideas of what a personal logo might look like, maybe you took the 130 class and you have some ideas of what your logo looked like there, obviously be thinking about it, and then we'll work through logos next class. Are there any questions? No? All right, I'll turn you loose.